Well, hey everybody, I'm Nick Pettit. My Twitter handle is @NickRP, and today we're going to be talking about 3D in the browser. We're going to get into, applications for 3D in the browser, why you might use it, what it's not, and a whole bunch of cool stuff. And of course, if I don't answer all of your questions by the end of this, or if there's something that you feel like you didn't quite understand, you can go ahead and post in the forum. And if you're a Treehouse member, you can post in the forum, ask your questions, and Treehouse students are wonderful moderators as well as Treehouse teachers will be happy to answer your questions. So that's a really great way to get help. All right, so let's talk about the state of 3D in a web browser. Of course, web browsers are more traditionally known for 2D graphics, right? Especially now with the flat design kind of taking over the world. We have the box model and CSS. Browsers are really good at displaying things in 2D. So that can be somewhat expensive though, because all of that processing is happening on the CPU. So in most computers you have a CPU, the central processing unit, as well as the GPU, the graphics processing unit. Web browsers traditionally haven't really taken advantage of the GPU. They've only really used the CPU, and that can be computationally expensive when you're rendering anything at all. The CPU is not optimized for rendering really anything other than very simple 2D graphics. So having the ability to use the GPU is really amazing, and that's what we're going to talk about today, using 3JS, WebGL, and a couple of newer technologies. So we talked about how there's kind of this separation between the CPU and the GPU. And on the GPU, like I said, you traditionally could not access that through the web browser. But now you can. And that's enabled with a technology called WebGL. However, WebGL is kind of complex to use in its raw form. It's a port of OpenGL into the web browser, and it doesn't have quite one-to-one feature parity with OpenGL, but it's pretty good. Of course, OpenGL is a graphics technology that's used to render real-time 3D games, so any kind of game you play on a Mac or on iOS, and even on some gaming consoles now, OpenGL is used very heavily to do real-time 3D graphics. All that tech is now in the browser in the form of WebGL. Browser support isn't great just yet. You can go to caniuse.com to check out the matrix of support for WebGL right now. I think, actually, let's go ahead and take a look at CanIUse to see what that looks like currently. And look at that, in the search they actually suggest typing in WebGL. So if you look here, support in Firefox is okay, support in Chrome is okay, Safari has partial support. Actually, Firefox has partial support, but it's supported it for a little bit longer. Safari, you have to actually go ahead and enable WebGL. It's not enabled by default, and it's only been recently supported in the latest version of Internet Explorer, and it's not supported at all on mobile devices. So that's something right up front you're going to want to keep in mind. When I'm talking about 3D here, one thing I'm not talking about is stereoscopic 3D. So we're not talking about the type of 3D that you might see in a 3D movie or a cinema or on like 3D televisions where there's two images and you have like a red and a blue channel and you wear 3D glasses and it's combined together to create this image that appears to pop out of the screen. Rather, we're talking about real-time 3D, similar to what you might find in a video game, where frames are rendered at roughly 30 to 60 frames per second, and everything has to happen in real time. So let's go ahead and take a look at what that actually looks like. As I said previously, using WebGL in its raw form is pretty tricky. It's a very low-level form of 3D graphics programming. But using a framework on top of that, of which there are a few, can make it a little bit easier to work with. So this is a framework called Three.js, and it's the framework we're going to be taking a look at in a little bit more detail today. We're going to create a very simple project. And if you go to 3js.org, you'll see all sorts of sample projects that are built using Three.js. So we have this race car here. This project was a music video. There's your Nyan Cat. You'll find a lot of games here. In fact, that's one of the primary applications of WebGL currently is in gaming. There's this pretty wonderful example of a car here. We'll take a look at that. And there's this example of a logo. I want to take a look at that. So this is being rendered in real time in the browser, and that's pretty amazing. This is, something that was not available for a really long time. I think this is kind of the evolution that people expected to happen maybe 10 or 15 years ago, back when, maybe even longer. I think people kind of expected the web to make this leap into more of a virtual reality type space where you can kind of, browse things in 3 dimensions. Oh, somebody just took over my mouse, I think. Oh, and it's back. Okay. I think this is the direction that people expected 3D to take some time back, and it never really did. But now it's here, and I think the lingering question is what to do with it. People don't quite know, what 3D should really be used for. One thing that, like I said previously, 3D can be used for is for games. Sorry, it looked like there was a magic mouse somewhere that's taking over control of my computer here. Okay, there we go. But 3D has kind of struggled to find its application in the browser. People have thought about using it for games, and in fact, there's actually a company that is trying to build a game engine using WebGL. Actually, they've already done it. They've built this really wonderful game engine, and they're trying to kind of recreate games like StarCraft. They're trying to build these real-time strategy games, and they've done a pretty great job. They, I guess, have generated a lot of interest, but so far, we haven't seen a whole lot out of Artillery just yet. Again, this is still early days for 3D. So one of the other applications, though, I think is products. So imagine you could go ahead and take a look at, a product like a car, for example, which is kind of a higher priced item, and, you might want to be able to take a look at what you're actually getting in more detail. And, it could be good for consumer electronics as well, where you go ahead and look at, an electronic device in 3D. You can kind of imagine maybe doing like the next iPhone this way, where Apple might use this newer browser tech on their site to show off, whatever new products they have on offer. But once again, 3D is still struggling to find its application in the browser. So that's something that remains to be seen. It's still early days here. One other cool application is to create some sort of logo or 3D effect like this. This is acko.net, or the blog of Stephen Wittens. And if we scroll down here, you can see that this is actually being rendered in full 3D here. And we can click on this little play button and it'll sort of play a music video. So that's pretty cool. You know, in the days of flat design here, it may seem a little bit out of place to see all of this nice shading and shadowing and, you know, sort of fancy effects like this. But I think that aesthetic will kind of come into its own, come back around, and we'll be able to use things like this a little bit more effectively. So anyway, those are some of the things that you can do with 3JS, and all those projects that you just saw were built in 3JS. There's a ton more stuff to check out here, so be sure to go to 3js.org and look at all of the projects. One thing that I have noticed is that movies are using this a little bit more. Let's see if I can hover over that. I think the new Wizard of Oz movie did some kind of 3D experience. There's that. The Hobbit had a pretty cool WebGL site. The site for Gravity is pretty cool. Kind of wondering if this is going to load up here. Let's see, app, special features. There's like a 3D experience they had here. Anyway, it's there, I promise. I'll let you check that out on your own time. So go to 3js.org and go ahead and check that out. So, how is this actually working? Well, it's kind of a combination of things you might have seen before and some newer things. So I have the Treehouse logo in 3D here, and this is the project we're going to put together real quick here. And this is done using a canvas context. So let me go ahead and open up Chrome DevTools here. I'm going to hover over and select that item. And you'll see that all that's on this page is just some JavaScript and this canvas, which is taking up the entirety of the browser. I also have a paragraph here, but that's just kind of overlaid. So let's go back here. 3JS will actually embed a canvas onto the page. So you do all of the stuff in 3JS, so just in pure JavaScript, and that will go ahead and create the canvas context on the page. It will give you your WebGL rendering engine. So that's one reason you don't want to code in straight WebGL. It's just going to be way too difficult to build your own rendering engine. So let's go ahead and dig into this code. One thing that, again, I do want to point out is browser compatibility. You'll likely want to do this in Google Chrome if you can, but if you're using Firefox or Safari, that's okay. It should still work just fine, except the only thing you have to do in Safari is go into Preferences here. So let me open up the Preferences, and then let's see here. You need to go to the Advanced tab. So let me pull that back up, Advanced, and then there should be, let's see, yes, Show Develop menu in the toolbar. And then you have to open the Develop menu and click Enable WebGL. And then WebGL should work in Safari at that point. So there you go. So I've included a couple of things here to get us started. One thing is the actual mesh that we're going to be using, or the actual geometry. And then the other thing is the orbit controls. So that's where we can go ahead and click around with the mouse and kind of drag our model around here, and we can zoom in and out to look at the model in more detail. And that's all the orbit controls do. Let's go ahead and open those up. This is all kind of complex code. You want to try to avoid writing yourself unless you have very specific camera controls in mind that you want to build out for a more specific application. If you can go ahead and reuse any of the controls that Three.js provides for you, you want to go ahead and try to do that. So let me go to Three.js here and see where these orbit controls are documented. One of the things about Three.js is that the documentation for it is not that great yet. Let's see. Camera controls, not finding it. All right. Bit controls Three.js. And my blog post on the Treehouse blog is one of the top hits. Wonderful. Living on the edge here. Okay. Wow, that's cool. Not what we want, though. So, well, I can't find where those orbit controls came from. I'm pretty sure I got them on GitHub when I originally wrote this blog post. But you can go ahead and download that code, and the orbit controls, as well as the mesh, will be included in the code download. So no worries there. So that should be all the JavaScript you need, the orbit controls and the model. Now this model I exported from Blender. Blender is a free 3D modeling application. You can use, I think, a couple of other exporters that Three.js has available. So let me see if that's documented. Pretty sure it is. Let's see, exporters, new, models, mesh, Blender. Nope. Oops. I think it might be one of the loaders or in the objects here. I think the documentation changed because I'm pretty sure that the exporters were detailed here at some point. Anyway, go to Blender, pull that up, and Blender 3D exporter. There we go. So Blender, like I said, is a free 3D modeling application. You can go ahead and get that at blender.org. And then there is an exporter for Blender that you can install to export your 3D models. So once you install Blender, you can go ahead and create your 3D scene here, and then you can go to File, Export, Three.js, and you can go ahead and save that out. I have already done that for the Treehouse model. So Treehouse logo .js is the model that you'll be able to download in that code download, and the code will look something like this. And the way that it's formatted is, well, there's a couple of things here. First of all, it's JavaScript object notation formatting. So there's some metadata about the mesh. And then there's all of the vertices. So right here is where all of the geometry is stored. And you'll find that this is pretty huge here because there's quite a lot of geometry in that model. There's what are called surface normals. There's all of the faces, so those are all of the triangles and basically where they're located in 3D space. And then we have a material here, which is a concept in Blender that you can go ahead and use in Three.js as well. So we have the ambient color and the diffuse color, and I think that is just an RGB color here. Yeah. So you can see 3 values here for red, green, and blue. So that's how you get models out of Blender. You can use other 3D apps as well, and I believe there's exporters for a couple of different popular ones like Maya and 3ds Max, and that will give you your geometry. Then there's Three.js, which is pretty epically long. This is the entirety of Three.js. It's all compacted and minified like this, but like I said previously, best way to navigate Three.js is to use their documentation here at threejs.org, and you can go ahead and look at all of the various concepts in Three.js that will help you build out your scenes. So let's go to the index.html file for this particular project, because this is where really everything is built out. So we start out this project. Let me just pull this up here. There we go. We start this out with a couple of variables. There's the scene, the camera, and the renderer. And then we make 2 function calls to the initialize function, or init, and the animate function. Now, it might not seem like there's any animation happening here, but there actually is a little bit, because whenever we drag around the orbit controls, we need to update the scene. We need to update the frame and what we're actually looking at. So this is animated. I mean, we have to render every one of these frames. So let's go back and let's look at these 2 functions. You'll see that we're doing all this in a fairly small amount of code. This is the entirety of index.html for this project, and really everything's happening just between these 2 script tags. So it looks like we're looking at just like 80 lines of code there or so. Actually less than that, about 70. So it's not too bad, and a lot of this is comments too, remember. So let's look at each one of those variables. Scene here makes a call to a new Three.js scene. And then it sets a width and a height for that scene using the window inner width and the window inner height. Now this is just straight up JavaScript right here. You're making a call to the window and getting its width and height, and then we're storing that in a variable so that we don't have to call the width and the height over and over again, because that can get pretty expensive. We're just calling it once and we're reusing it. But what is this scene here? Well, let's go ahead and dig into the documentation. And let's look at scene. I think that might be under cameras, actually. There's a scene loader, scenes. Ooh, that looks like what I want. Okay. So scenes allow you to set up what and where is to be rendered by Three.js. This is where you place objects, lights, and cameras. So in our scene here, we're basically setting up a couple of things. It's the object that we're going to be using to set a couple of other things, right? And it basically defines the space in which our 3D world exists. So next, we have to pick a renderer. And Three.js comes with a couple of different renderers. We, of course, want to use the WebGL renderers. Let's see if I can pull this up. Here we go. We want to use the WebGL renderer because it's going to create a WebGL context in the browser that will go ahead and use the GPU, whereas we could use the Canvas renderer here, but it's going to be a lot slower. At one point, I think Three.js had an SVG renderer, but it doesn't look like that's part of Three.js anymore. All this stuff does change pretty quickly, but the Canvas renderer is going to be a lot slower, and it's really not. It's just going to be orders of magnitude slower. It's a software renderer. So using WebGL will allow you to access the GPU. So we're going to say WebGL renderer, and we're going to set anti-aliasing to true. So let's see what that means. We'll go to the WebGL renderer, and anti-aliasing, it says, is a Boolean, which means it can be true or false. And let's go down to anti-aliasing. Oh, well, that's the only place it's listed. That's all right. Anti-aliasing basically means that it's going to smooth out the jagged edges along a 3D model. So if I were to turn this off, let's go ahead and do that. So let's say anti-aliasing is false. You'll see that it looks a lot more pixelated. You get kind of these jaggies along the edges of the model. And that's not really aesthetically pleasing, so we want to keep that set to true. Here's where we set the size of the renderer. We want the renderer to be the same size as the width and height of the scene. That might seem obvious, but there may be certain contexts where you don't want to do that. And then we take the renderer and we append it to the body of the document. And if we look at index.html here, just to kind of get a broad overview of its structure, we're including Three.js, we include the orbit controls, we have this JavaScript here, and then we close out with the body tag. So, like I said, everything's happening in JavaScript. We're actually appending the canvas element to the body here. So there's our body, there's our canvas, it has a width and a height, and that's happening right there on line 31. So next we need to create a camera. We actually can't see anything in the scene without a camera. If I were to just comment this out, I'm actually not sure what's going to happen. Yeah, it's not going to render anything. That can be the frustrating thing about 3D, is if you get something wrong, there's not great error outputs. This might be the best it's going to do for you. So don't get frustrated if you don't see anything in the browser. It probably just means that you skipped one of these steps here. So camera is a new Three.js perspective camera as opposed to an orthographic camera, I think. Let's see, yeah, as opposed to an orthographic camera. Now, I wonder if that has the exact same arguments. Let's just go ahead and stick that in to see if it will still render. Not quite. What is it expecting? Left, right, top, bottom, near, far. Okay. Yeah, that's not going to match up quite right with a perspective camera arguments. That's okay. Basically, this will create more of kind of a flat look. It won't be rendered in perspective. Actually, I wonder if I can show this in Blender real quick. Let's see. My Blender foo is off today. That's okay. Anyway, we want to render this in perspective. And the perspective camera takes a couple of arguments. You need a field of view. So we've set that to 45 degrees. Let's go back to our code here. There we go. The aspect ratio of the camera is simply the width divided by the height. And so once again, we're using the window inner width and inner height, and we're just pulling that once, storing it in a variable instead of having to call that over and over again. So width divided by the height, there's our aspect ratio. And then the near and the far plane, that is basically how far out something has to be from the camera before it will stop rendering, or how close something has to be to the camera before it will start rendering. So, I've got my example back here. If I were to say, let's see, this is 6 units away from the model. If this were something like 15, I think we should, oh, doesn't even render. 10, nope. Let's see, 5. There we go. So here's something weird. We're 5 units away from, or rather, if we set the near parameter to 5, the camera isn't actually going to start rendering anything until the object is 5 units away. So if I zoom out a little bit, there we go. Now it's 5 units away, but if I zoom in too much, it's actually going to clip into the geometry. Same thing with the far plane. So let's see if we can get that to clip. If I set that to 20, nope, still not enough, 5. Oh yeah, there we go. There's some weirdness as well. The far clip here is, you might have seen something like this in a video game where if you're trying to look far off into the distance, you'll notice that it doesn't render like distant objects very well, or they kind of pop into the world all of a sudden. That's basically all that's happening, is the far render distance just isn't quite far enough. Of course, the larger that range is, the more processing power you need to render the entire scene. You know, there could be a lot more geometry that's having to be rendered onto the GPU. It's that might be something to cut if you have various performance considerations. So now we're setting the position of the camera. So once again, we have the camera, which we created as a new Three.js perspective camera. And then we can go ahead and set its properties. So if we go down here, there should be position somewhere. Position. Oh boy. Doesn't quite look like it. Actually, you know what? I bet that's just a property for all objects in Three.js. This might be, yeah, position. Let's see if I can search for that. Let's do this. Cameras. Object 3D. There it is. There it is. Okay. So position is what's called a vector 3. It's 3 float values, which are just the x, y, and z coordinates of a particular object. So you can set this for any 3D object in Three.js. So camera inherits from object 3D, and that's basically how we're getting that vector 3 there. So we set that to x, y, and z, 0, 6, 0, and then we add the camera to the scene. So let me just get back to my example there. There we go. Now, here's an interesting bit of code. What happens if we resize the browser window? Well, a couple of things have to happen. First, we need to add an event listener to the window to listen for resizes. So when I resize the browser, it's actually fairly expensive computationally to do that, because now I have to reset width and height, right? I also have to have an event listener to watch for any time the browser is resized. And then I need to set the size of the renderer again. Remember, we did that earlier. We need to change the aspect ratio of the camera. So camera.aspect. And then we need to update the projection matrix for the camera. What does that mean? Let's look. We'll go to camera, update projection matrix. So it says this updates the camera projection matrix. Very descriptive. Must be called after a change of parameters. So basically, anytime you're going to adjust something like the aspect ratio or the field of view or really any other camera parameters, you need to call this function update projection matrix so that things like this don't happen. You can see how I'm adjusting the aspect ratio and it's kind of warping and stretching my view here. So let's turn that back on. Boom, there we go. Now, renderer.setClearColorHex sets the background color of the scene, and it accepts 2 arguments here, a hexadecimal color, and I think that's alpha. Let's try that. Let's see. Yeah, I think that's the alpha channel. So if I set that to like 0.5 or some other float value, it'll be slightly transparent. But that's just setting the background color of the renderer. Pretty simple there. If you're familiar with hexadecimal colors in CSS, this is the same thing. You just have to add 0x to the front of it. Next, we need to create lighting. So let's go ahead and delete this light, see what that looks like. This is what this 3D world looks like when there's no light. It's completely dark and you can't see any kind of color or really anything about this model other than its shape and the background. So first, we create a light, and the type of light we want to create in this case is a point light, and then we set the color of that light. So again, let's look at the documentation. Go to lights. There's point light. And pretty much just as we're doing in this example is what they're doing here. It takes a hexadecimal color, a numeric value, the RGB component of the color, intensity, numeric value of the light's strength or intensity, and then distance. So we're just setting the color here. These other arguments are optional. And then we're setting the position to x, y, and z. Again, this is a vector 3 to -100, 200, and 100. And then we add the light to the scene. That's it. It's pretty simple. and that's what gives us our lighting. So if we were to change this to something else, let's see, this is probably going to look really ugly. Trying to get color here. There we go. Something like bright red, no green, and kind of a medium amount of blue, which is this purplish color. It will cast that color lighting onto the model. But I'm just going to set that back to white, and that will give us our color back. So now we need to load our mesh into the scene. Here we're using the JSON loader, or JavaScript Object Notation Loader. There's a couple of different loaders in Three.js. Let's go to, yep, there we go, the JSON loader. So you have to create the loader, and then you have to tell the loader that you actually want to load the geometry. So let's split out these arguments so that we can read them a little bit better. Let's see. Right, there we go. So I'm passing in two things here. One is the URL. So a mesh in Three.js is just a URL, just like you might include a CSS file or a JavaScript file. You go ahead and say, this mesh is in models. It's called treehouse_logo.js. Pretty straightforward stuff. The next is a callback. And it says this function will be called with the loaded model as an instance of geometry when the load is completed. And then inside of this, I'm saying I want to load this mesh Lambert material. So let's look at that. And basically, all that's doing is just setting a color. So I load the material. I say, I just want this basic diffuse color of 55B663. So that's just a hexadecimal color, and that's green in this case. I'm just saying I want this mesh to be green. I don't have any other textures I want to apply. So for example, you could apply texture maps, environment maps, reflectivity, all sorts of shaders, surface normals, etc. We're not going to do any of that. Then I say, okay, that's the mesh that I want to add. We create the mesh, and then we add it to the scene. So a little bit complex there, but if you look at the basic formatting there, there's actually not a whole lot going on. We're just loading in the model and loading in the material. So then we add the orbit controls, and I really thought that orbit controls were part of Three.js. So I guess this is just, it's just extending that particular namespace and adding orbit controls. So, oops, there we go. So the orbit controls take two arguments here. It takes the camera, and then it takes the renderer. And that will just allow us to tie basic mouse, just the basic click and drag functionality, zooming in and out with a mouse wheel, and allows us to kind of move around our mesh a little bit more easily. So all that stuff we just went over is the initialization function. It gets called right here. Next is the animate function, which is here, and there's three things happening. First, we're calling request animation frame animate. What is that? Well, Paul Irish wrote this wonderful blog post about request animation frame, and it says, in your animation work, you've used a timer loop to make changes every few milliseconds. Browser vendors decided, hey, why don't we just give you an API for that, because we can probably optimize some things for you. So the browser is always going to be faster than any kind of JavaScript code that you're going to write. So all it is a basic API for you to use with animation. So that could be changes you make to the DOM, so styling changes, could be something that's happening in a canvas, could be something that's happening in WebGL. But if we just call that there, anytime something changes, it will go ahead and be a little bit more efficient than what we would otherwise code. So that's just a straight up API call to the browser. Then we go ahead and render the scene. So we make a call to the renderer. So remember, that is a variable that we created outside the scope of both those functions. And then we say render the scene and the camera. So let's go back to the documentation here. And let me see if we can pull that up. There we go. So we have the WebGL renderer here, and we make a call to the function render. Let's see if I can find it. There we go. And the renderer, again, we're using here is the WebGL renderer, and we give it a scene and a camera. So we created that scene, and we created our camera in the scene, and that will go ahead and build it out anytime we need to animate something. And then we also need to call controls update. So that's just a function call here. Let's see. Oops, controls update. I can't find it. It's somewhere in there, I promise. Anyway, we update the controls, and that's pretty much it. That's kind of a basic of Three.js scene. And you end up with something that looks like this. Now, there's a slight problem with just downloading this code and viewing it in your browser. So if I try to do this, so I just have the code I downloaded, right? And I just opened up this file in Google Chrome. It doesn't look like anything's happening. You know, there's absolutely nothing being rendered here. The problem is that you have to kind of set up your local environment to be actually running a server. So in this blog post, I said JavaScript has a security feature called the same origin policy. And you can read all about that on Wikipedia. Basically, all it is just a security feature of JavaScript. That means you can't load externally hosted files inside your JavaScript code. And the problem with that in Three.js is right here. Where is it? There we go. Right here, we're doing exactly that. We're trying to call another piece of JavaScript inside of our file, right? So you can't do that. You have to have the same origin. And we don't have the same origin on a local file server. So you need to go ahead and actually create this yourself or start running a simple server. I like to use a Python server when I'm doing local development work like that. So if you have Python installed in your computer, you can just go ahead and type Python with an M argument, simple HTTP server, and then you specify a port number. And that will go ahead and start up just a simple HTTP server. So you go to localhost :800, and then you can navigate to whatever folder your project is stored in. So it will go ahead and list out the directory here. I can click there, and it will load up my project because now we've circumvented that same origin issue. This isn't really a problem when you upload to a real server, but it can be a bit puzzling if you're just starting out and you try to download the project and nothing's appearing in the browser. I think there's one more thing I want to look at first here, and then we can take some questions. Let's see. I have a Chrome extension installed. See if I can find that. Yes, the WebGL inspector. Go ahead and load up the page for that. So this is just a debugging tool that can help you kind of dig into WebGL scenes. It's not a great screenshot of it, but it will also kind of give you a hint as to whether or not there's a WebGL context being loaded up. So I'm just going to click on these little controls it gives here. And I can see if any kind of textures are being loaded up. Not in this case. And you can look at other bits of information here. Let me look at a more complex scene here just to show this in a bit more detail. Let's go to Three.js. And let's go back to our car example. There we go. And doesn't always work perfectly. Okay. There we go. And you can kind of start to see how some of these things are broken out into various textures. Looks like a lot of these textures are just to load up the room. Let's see if I can refresh there and remove that. No, I broke it. Okay, well, that looks like a good place to stop and take some questions here. Jason asks, any thoughts on using 3D like this as a progressive enhancement? So progressive enhancement is basically where you have kind of more of a basic look to your site, or you're using more basic technologies, and maybe more advanced technologies aren't necessarily supported in a browser. I'm explaining that really badly, but yeah, you could definitely use this as a form of progressive enhancement. So, for example, if you were looking at maybe a 2D picture of like a product and you wanted a more enhanced version of that for browsers that supported 3D, you could go ahead and certainly do that. Maybe just swap it out or detect whether or not WebGL is enabled in in that person's browser, and if it is, go ahead and just swap out the image and load up your 3D context. Nick asks, have you seen what Epic Games is doing with the Unreal Engine in the browser? Do you think we'll see that sort of tech applied to non-gaming web content in the future? Possibly. Let me go ahead and show you in Firefox here. Let's see. What am I looking for? Firefox, Unreal Engine. Here we go. This is probably going to take just a second to load up here because there's a lot of geometry and textures it needs to download. Let's see what that question was again. Have you seen what Epic Games is doing with the Unreal Engine in the browser? Do you think we'll see that sort of tech applied to non-gaming content in the future? Possibly. So, oh my gosh, this website is attempting to use more than 50 megabytes of data on your computer for offline use. Yes, that's fine. There we go. So let's make this bigger. So this is a pretty impressive tech demo from Mozilla, and using the Unreal Engine. I think it only works in Firefox. Actually, I tried it out in Google Chrome and it seemed to work okay. But they're using all sorts of fancy effects here. So, for example, if you look at like this brick texture here, you see how they're applying lighting to the bricks, and they kind of look sort of 3D-ish. That's usually using an effect called normal mapping. So they have normal maps, bump maps, and a diffusion map to kind of model a lot of the geometry that would be fairly expensive to model with triangles. So instead, they're just doing that with texture maps. Whether or not we'll see this type of technology applied to non-gaming contexts, I'm not sure. I mean, I think that's something that's kind of interesting about 3D right now, is it's really pretty open-ended. I think a lot of people wanted this technology for a long time, and now that, can I get rid of this tutorial? There we go. And now that we have it, it's kind of this alien in the browser, I guess you could say. It's hard to really find a real application for this. I mean, it's certainly cool, and it will certainly, look impressive on a resume. But there we go. There's a nice view of the castle. I think this type of thing is going to be useful for products. I think, if you have a high-priced product like a car or a phone or some other consumer electronic that may involve more of a purchasing decision where somebody really needs to think about whether or not that's actually worth their money, then it totally makes sense, because it can be difficult to try before you buy in some instances. So it'd be nice to kind of have, a 3D model that you can turn around in the browser and look at and interact with. That's the important part of this, is that it's all interactive. So you could, have that model of a car and have the car door open up. You could go inside the car. You could look at all of the dials and gauges, kind of click on all of the buttons. You could even take that car for a test drive in the browser and kind of, drive it around this imaginary course. There's all sorts of stuff you could do. And I think that's really where 3D in the browser will start to make a little bit more sense or see more practical use. But like I said, people are building games with this. So, I mean, the Unreal Engine, or at least Unreal Engine 3 here, has been ported over. And there's also Artillery Games, which are, let's see. So they're a company. They're trying to build, this game engine in the browser. They're building this real-time strategy game, and I guess they're planning to open source all of these tools or make this kind of stuff available to developers. They are using WebGL. They are not, however, using Three.js. At least I don't think they are. They're building their own rendering engine, which is ambitious but kind of neat. So last question, is there a parameter to control the camera's focus? That's interesting. So probably, I'm sure that you could, if you maybe wanted to do sort of a depth of field type effect. Let's see. If I can find that. There we go. Yes. So set lens, you can set the focal length and you can set the frame size. I actually want to try that right now. Let's see if we can make that help. Or make that work. This is just a tutorial for 35mm lenses. Not terribly useful. So focal length uses focal length in millimeters, okay, to estimate and set field of view 35mm. Full frame camera is used if frame size is not specified. This may or may not do what we want, but let's just try it out anyway. See what happens. Oops. So, right up here where we're setting our camera parameters, we could say camera. What was the argument? Set lens. Okay. Set lens. Ooh, why isn't that working? Perspective camera. Yeah. I'm just gonna see if this does something. Save that. Oops. Wow, that's definitely having some kind of effect, isn't it? Whoa. Well, I think the lesson here is that I don't really know a whole lot about focal lengths, and I should have read that tutorial. All right. Well, that's that's pretty much all we're going to get into today. I am Nick Pettit. My Twitter handle is @NickRP. We do these every Tuesday at 2 p.m. So hopefully I will see you next week.